What the AggLayer enables is it basically like quarantines each chain. And it says, okay, even if this chain has an unsound prover, the security assumption reduces to the case that it's the only chain in the ecosystem. So an attacker might be able to rug users by exploiting a soundness bug in that prover, which is the exact same case as though the chain were running on its own without this shared deposit contract. But it fundamentally can't threaten funds that are locked in other chains on the AggLayer.
Hi, everyone. Welcome to Unchained, your no-hype resource for all things crypto. I'm your host, Laura Shin, author of The Cryptopians. I started covering crypto 8 years ago, and as a senior editor at Forbes, was the first mainstream media reporter to cover cryptocurrency full-time. This is the April 9th, 2024 episode of Unchained. Polkadot is the original and leading Layer 0 blockchain with over 2,000 plus developers. And the Polkadot 2.0 upgrade will be a massive accelerator for the ecosystem, making it faster, more secure, and adaptable. Perfect for GameFi and DeFi to build, grow, and scale. Join the community at polkadot.network/ecosystem/community. Today's topic is Polygon and its new AggLayer. Here to discuss are Marc, CEO of Polygon Labs, and Brendan Farmer, co-founder of Polygon. Welcome, Marc and Brendan.
Thanks for having us.
Thanks, Laura.
So I actually don't believe we've done a show that just focused on Polygon, at least not in a deep dive format. So why don't we just start with a brief primer and your backgrounds? Brendan, do you want to go first?
Yeah, sure. So I'm Brendan. I work on zk R&D, mostly at Polygon. I joined Polygon actually as part of an acquisition. So I was previously working on a project called Emir, which was a zk focused L1 that was acquired by Polygon in 2021.
And Marc?
Yeah, I'm Marc Boiron. I'm the CEO of Polygon Labs. And before being CEO, I was the chief legal officer at Polygon Labs. And before that, chief legal officer at DYDX. And before that, counsel to plenty of different companies in the space.
All right. And let's just give a brief description of what Polygon is before we dive into all the stuff you guys are up to.
Sure. So Polygon Labs is a development company that's been developing a suite of Ethereum Layer 2 scaling solutions. And so the one that we are most known for is for having developed Polygon PoS, which is a proof of stake network. And we've also launched Polygon zkEVM, which is a full ZK secured rollup on Ethereum. And now what we're focusing on, in addition to kind of scaling through these different networks, is scaling between networks as well, which is where the AggLayer comes in.
All right. So now let's dive into details on that. We've had this debate about monolithic and modular blockchains going for a while in the crypto space. And in February is when you launched this AggLayer, which claims to offer the benefits of both. So explain what the AggLayer is and how it offers both of those benefits.
Sure. So the AggLayer, I'll give like a technical kind of jargony explanation and then go into what it means. So the AggLayer is a decentralized protocol that enables basically two things. So it enables cryptographic safety for cross-chain interaction at lower latency than Ethereum finality. So it allows you to like safely send messages and execute transactions across chains very, very quickly. And the second thing that it allows is it allows a bunch of different chains to all use the same native bridge. So users can bridge L1 and L2 native assets seamlessly across chains in the AggLayer ecosystem. And so if we take a step back and think about like the current state of rollups, if I want to move funds or do something with my funds that are currently on Polygon zkEVM, I want to do a swap on Arbitrum. I need to route that interaction through Ethereum. So I need to withdraw my funds on Polygon zkEVM. I need to wait for a proof to be generated. I need to wait for that proof to be verified and finalized on Ethereum L1. And then I need to submit a deposit transaction on L1 and wait for that deposit to become finalized before I can access my funds on Arbitrum. And so all in, this takes like 45 minutes. And that's like a state of the world that I think is incompatible with good UX and with like taking an ecosystem that's currently fragmented, which is the Ethereum L2 ecosystem, and unifying it so that it feels like a single chain. And so when we talk about like the modular versus monolithic debate, like I think both sides sort of have a point. The monolithic side is right that like what we mean when we talk about scaling in crypto is scaling access to liquidity into shared state. And so if we're creating this ecosystem where we have a bunch of chains, but state and liquidity is fragmented across all of them, then we're not really succeeding in doing what we're setting out to do. And I think by contrast, the modular side is right that like a single chain can't accommodate the throughput required to like fulfill this vision of the value layer for the internet or the internet of value. And so I think the way we describe the AggLayer is sort of, or the aggregation thesis is sort of like the synthesis of these two views, like the ability to add block space in a modular way, but unify that block space so that it feels like you're using a single chain.
And like just to talk a little bit about that user experience. So when people are using the AggLayer now, is there any difference? Like when they're, I guess, kind of on-ramping into there, is there something new or different? Or is it really more just about the experience once you're in it that's different?
Yeah, so I do think we have to like set expectations. The AggLayer is not currently live. What's currently live is a shared bridge that's shared by two chains in the AggLayer ecosystem. When the AggLayer is deployed and when we have this sort of infrastructure that allows for fast interactions between chains, then I think your description is correct, where like within that ecosystem, we can solve fragmentation and we can unify and we can have like super low latency interactions. But there will always be friction when you're coming from L1. There are some caveats there, like we could have what's called like base sequencing and base rollups, which can kind of improve that a little bit. But in general, the AggLayer is designed to erase fragmentation and friction once you're in the ecosystem.
And I think one thing that's worth pointing out, Laura, is that like when we talk about this friction going from like L1 to L2, I think it's a friction that's not really a comparison to L1s that is fair, in the sense that if you think of like, how do I actually get onto an L1? The answer is you go to an exchange and you buy the L1 token, and then you move it to your wallet on L1. And this is the same thing for L2s. You just have this added advantage that you could go from Ethereum. But most of the time for L2s, what you're going to do is you're going to buy ETH on an exchange, and then you're just going to send it to the wallet on the L2, and you're going to start using it. One of the benefits of the AggLayer by bringing this all together in this aggregated way is that all you would need is one chain that is part of the AggLayer to have that on-ramp from that exchange for all of the other chains in the ecosystem to be able to receive that. So, for example, right now we've got Polygon zkEVM and A* that are both on the unified bridge that will be part of the AggLayer. By simply going straight to zkEVM, or by one connection to zkEVM or one connection to A* from a centralized exchange, you could then go to either of them. One good example of how this is going to play out with once Polygon PoS joins the AggLayer. Polygon PoS has been around for so long that it has connections to like all of these exchanges. And so you'll just be able to like on-ramp directly through Polygon PoS to any of these other chains that are part of the ecosystem. And so you end up having that same feel without ever needing to go from kind of Ethereum to the L2 in the first place.
And then if we compare to similar systems, there's Optimism with its superchain, and then Cosmos has been working on interoperability for a long time. And so some of the ideas that form the basis for the AggLayer aren't necessarily new. So how would you differentiate the AggLayer from those other efforts?
Yeah, so the way that I would draw a distinction is I think zk technology unlocks a lot for the user experience and for how we think about bridging and movement of assets between chains. So like if you think about Cosmos, when I bridge between different chains in the Cosmos ecosystem, like I'm not getting the same assets that are fungible on my destination chain. So like if I'm bridging from let's say ETH from one chain of the Cosmos ecosystem to another, what I'm getting on the destination chain is a wrapped synthetic version of ETH that's not necessarily fungible with the native version of ETH on that chain. And so with ZK technology, what we can do is we can allow chains to that settle on Ethereum to share a deposit contract, and that enables us to take or to allow users to take L1 native and L2 native assets and bridge them seamlessly across chains. And further, it sort of opens up the space of like the cross-chain interactions that can happen. So if you think about like an atomic bundle of transactions, like maybe I'm a DeFi trader, or I want to do like a cross-chain arbitrage, and it's really, really important for me that all of the transactions in this bundle of transactions that I'm submitting actually execute successfully, or like my trade might not be market neutral, or something bad could happen to me. This is not really possible in the Cosmos ecosystem, but it's something that we can enable in the AggLayer, and it's something that we can guarantee safety for, because the AggLayer gives a cryptographic guarantee that, like, for me as the operator of a chain, my chain can only be settled to Ethereum if it's like consistent with the other states of chains that exist in this ecosystem. And so I really think like ZK technology is sort of the missing piece that unlocks like a much, much better user experience versus Cosmos. And obviously, I think in the optimism case, if you think about like what the drawbacks are for fraud proofs, in order to do bridging through the native bridge, we need to wait for the like challenge period for fraud proofs. And so that limits what we're able to do in terms of moving assets seamlessly across chains, in terms of triggering cross-chain interaction without relying on third-party bridges. And so I think if you look at like what the actual characteristics are from a security and from usability perspective, like third-party bridges are not really as great a solution as native bridges, because they expose users to security risks, they're capital inefficient, they rely on there being liquidity on the destination chain. And so if we think about like the end state of crypto ecosystems, which consist of like hundreds or thousands of chains, I think the AggLayer vision is one that's like much more likely to make that a good user experience than different competing views of the world.
So primarily is the benefit really just the lack of that delay period, like the low latency? Is that kind of the main thing that gives that sort of seamless, interoperable experience?
Yeah, so it's low latency and also fungibility. So the fact that I can just like take ETH on zkEVM, I can bridge it to the OKX chain, do a bunch of stuff, and I'll like get ETH on the OKX chain. I don't need to worry about there being like a liquidity provider that's able to swap into the native version of ETH on that chain that's used as like the pair and all the AMM pools. I can just like not even think about the sort of boundaries or like the trust boundaries between chains. I can operate as though it's like one single expansive unified block space.
When you think about that in the context of DeFi, it does allow for much deeper liquidity in that ecosystem than what you would get otherwise. And this is kind of what Brendan was touching on. When you have a wrapped version of an asset, it doesn't sit in the same pool as the native version of that asset. And therefore, liquidity in each of those pools can never be as deep as if you just have the native version all sitting in one pool. And so when it comes to like, the execution experience and price experience that, DeFi users can get, it's much better in one that has like a native asset across the entire ecosystem, which is what monolithic chains kind of receive and modular chains don't. And the AggLayer kind of brings it together so you do get that in kind of the modular state.
Can you just walk through kind of what this will look like when there are more different apps on the AggLayer or more chains? What's an example of something that somebody could do in that environment that isn't quite possible today?
Yeah, sure. So I think one thing to sort of point out is like the AggLayer really like works in a complementary way to what we call emergent coordination infrastructure. So we can think about the AggLayer as being this like foundational piece of infrastructure that's providing a cryptographic safety guarantee and also enabling chains to share a bridge. And then on top of that, there are coordination mechanisms like shared sequencers or relays or builders that are building blocks across chains. And so one thing that you could think about is if multiple chains in the Polygon ecosystem are using a shared sequencer, then at any particular slot or block, they're able to share a proposer. And that proposer is able to delegate the ability to build blocks to a single builder. And by builder, we just mean some other party that's not necessarily a validator of any particular chain, but is able to operate in sort of like a much more sophisticated and professionalized way than like a validator with low hardware requirements. And so what we can think about is like at a particular slot, this builder is actually simultaneously building a bunch of different blocks across a bunch of different chains. And maybe a user is like interacting at the same time across a bunch of different chains. And so we can think about like, maybe I keep my funds on Polygon zkEVM and I want to like mint an NFT and then swap it and take out a flash loan or some like very convoluted and sophisticated DeFi interaction that's happening across a bunch of different chains. Then that builder like is executing all of those transactions simultaneously across a bunch of different chains. And so it can determine if any of those transactions fail. And if they all succeed, it can package those transactions together as a bundle and include those in a block that's executed across like all different chains that are sort of within the zone of this shared sequencer. So I think that's like an example of chains that are being unified and really feel like a single consolidated block space versus like the current like mode of interaction in this example would be like, I have funds on one chain. I need to bridge via third-party bridge or via native bridge to the NFT chain where this mint is happening. And then I need to be bridged back to the DeFi chain. And it just ends up being like, first of all, a very complex process because the user has to reason about how to get to all of these apps that are actually located on different chains. And it also ends up being like an expensive one because at every step, I need to either accept a huge amount of latency, which could impact my ability to execute my transactions, or I need to pay third-party bridges. I think this example like illustrates that like users will be able to reason about applications and the applications that they want to use. They won't need to reason about like where those applications are located in block space across this ecosystem. And I think that that's like sort of analogous to how the internet works. Like I don't think about if I want to access a website in Europe, I don't think about like bridging my packets across the Atlantic Ocean to get to this website that's hosted in Europe. I think about like using the internet as a unified environment for information. And I think of the AggLayer as sort of being a similar concept where it's a unified environment for state and liquidity.
When you think about this from like a really like practical perspective, right? If you take an example, you can imagine an exchange like OKX. They are joining the AggLayer, which is actually happening. That's not an example. From that exchange, what a user would do is they would send assets over to the OKX chain, and they might want to hold DAI, for example. They could exchange, some ETH to DAI on OKX chain, and then in the same user interaction, go ahead and transfer that DAI to another chain, to A star, and purchase an NFT with that DAI on A star, and in that same user interaction, kind of bring it back to their wallet on that OKX chain. And so that ends up being kind of the same feel that you would have in a kind of monolithic chain where you just have like one user interaction and you can execute multiple transactions. It's doing the exact same thing, but on chains that have different attributes. And the question is like, why does this matter, right? And the answer is simply that NFT that you purchased sitting on that specific chain, probably for most users can create a much better user experience, given that they control the entire environment on that chain. They also don't have to worry about things like cost spiking because they control their own block space. And so you end up kind of getting those benefits of like a great user experience, but without giving up the interaction of just kind of one click to execute these transactions as you would be able to do in a monolithic chain.
And just understand about the OKX chain, which I guess is called X1. Is that sort of similar to Coinbase's Base, where they have, their own?
Yeah, that's right.
So something else that I was curious about, from what I read, it seems even Solana virtual machine chains can use the AggLayer. Is that correct?
Yes.
Yeah. Can you talk about how that works? Like, I don't know if it's literally just what you described before about the block producer, what I don't know what you called it, where they're simultaneously doing this on multiple chains. Is that, just talk a little bit about how that works?
Yeah. So I think that's a really good question and a good thing to point out. The AggLayer, like, fundamentally is not, it tries to not be opinionated whatsoever. So a chain can join and they can use their own token for staking and for gas. But one of the things that we thought was really important was enabling them to use their own execution environment. So for certain applications, like the SVM might be a much better choice than the EVM, or like a custom execution environment that's written in Rust and maybe compiled with a general purpose zkEVM, so they get like a prover for free, might be like a very good trade-off for like a certain type of application. And so for us, like, there's no requirement to use the EVM or zkEVM, and we've architected the system such that each prover or each execution environment that joins the AggLayer doesn't create like an additional security risk for any of the other chains that are using the shared deposit contract and shared bridge of the AggLayer. So I think that's like a very nice property, because it means that developers are completely free, like, not only to customize how their application works, but actually to customize the environment that it runs in. And to Marc's point, I think that this will be like a very powerful thing for chains.
So we've talked about this prover a few different times, and I don't remember if we've defined it, but it's for the zero knowledge proofs, it's like creating those proofs, right?
Yeah.
And so they're doing it for all the applications or all the chains, no matter what kind of chain it is.
Yeah. So the chain would create or would generate its own validity proof. But I think you're touching on like a very sort of like subtle thing that's actually really important, and that is like let's say that we didn't have the AggLayer, and all that we had was like a shared bridge or a shared deposit contract, and we wanted to support like a heterogeneous set of execution environments that would each have their own prover. The problem is that if we want to make this permissionless, then for every prover that we admit into this system, there's some probability that there's an undetected soundness error or some sort of bug that could be exploited by an attacker. And so for like, as we admit more and more chains into the ecosystem, that probability goes up. And so it actually ends up being a very bad thing, because like by the time we get to like prover number 1000, there's actually a fairly high probability that at least one of those provers has a soundness bug that can be exploited by an attacker. And so what the AggLayer enables is it basically like quarantines each chain. And it says, okay, even if this chain has an unsound prover, the security assumption reduces to the case that it's the only chain in the ecosystem. So an attacker might be able to rug users by exploiting a soundness bug in that prover, which is the exact same case as though the chain were running on its own without this shared deposit contract. But it fundamentally can't threaten funds that are locked in other chains on the AggLayer. And so this is, I think, a really important and maybe underappreciated aspect of the design of the AggLayer, is like being able to support two things that are in tension. So first, having a shared deposit contract, which we think is really important for asset fungibility and for user experience, but not imposing security risk or a security cost on other chains that are in this ecosystem.
Okay, yeah. I mean, that's it sounds like a really smart architecture, because obviously we've seen in crypto that there's a lot of crazy stuff that can happen when it comes to security. So you've also launched. So I saw you've launched this Type 1 prover. I saw it also mention a type 2 prover. Can you talk a little bit about the distinction between those?
Mark, I'm sorry that I'm like talking more.
Dude, it's okay. Well, while we're in the technical stuff, it's all you.
Yeah.
Yeah. So the types of zkEVM provers it's actually a framework that was proposed by Vitalik, and so it's this spectrum where we go from like having complete EVM compatibility. So a type 1 prover is completely EVM compatible, even to the point of being able to generate proofs for existing EVM chains. So you can take this type 1 prover and you can generate validity proofs for the Ethereum L2, for the Polygon PoS chain, for like the Avalanche EVM chain. But there's sort of a trade-off because a lot of the way that the EVM is designed is not really friendly to like zero-knowledge proofs. So it uses cryptographic primitives like Ketchak or like the encoding for the Merkle trie, which are a little bit more expensive to generate proofs for. And so there's this trade-off where you have like, on the one hand, a type 1 prover where you have complete EVM compatibility. And then it goes to like a type 4 prover where you don't really have that much EVM compatibility, but maybe your system is built in such a way that the proofs are a little bit more efficient to generate. And so up until this point, Polygon's been really focused on like this side of the spectrum where we have a type 1 prover and a type 2 prover. A type 2 prover basically gives you an identical developer and user experience to the Ethereum version of the EVM. It's just it can't be used to generate proofs for existing EVM chains. And so with the release of the type 1 prover, we were really excited about this because like with the proving system improvements that Polygon has made, we were actually able to generate type 1 zkEVM proofs at a much lower cost, even than some like type 4 zkEVMs that are supposedly optimized for proof generation, but they're running on less efficient proving systems. And so when you actually look at the tangible cost, it ends up being like very, very cheap. So it's, for us right now, it's like between 1 and 2/10 of a cent to generate a proof for an average EVM transaction or an average Ethereum L1 transaction. But we expect this to decrease really dramatically in the coming months.
And so there's a chain called Conto, which is on Cosmos and had previously announced plans to become an Ethereum-based chain using your CDK or chain development kit. And they ultimately decided to stay on Cosmos, but instead use this type 1 prover to plug into the AggLayer. So from working with them, how would you advise teams that are in a similar position? You know, how should they think about their options? Like, when would it make sense for them to shift to Ethereum? When would it make sense for them to stay as is and use the prover to just plug into the AggLayer? What are your thoughts on that?
Yeah, I mean, I'll jump in here. And my view that I always start with is like, what are you trying to achieve for your users? And does your environment currently allow you to do that? And this is like the kind of non-technical version of it. But ultimately, my view is that like, we don't need to push somebody towards like the EVM or SVM or any type of environment specifically. The question is just, what do you want to build for your users and where can you build it best? And we ultimately do not care where a chain decides to build that, right? And so all we care about is, are we able to give you the ability to interact in a seamless way with chains that are also building a very specific environment for their sets of users? And as long as they're both able to do that, we want them to be able to interact in a seamless, low cost and low latency way. And that's what we're ultimately allowing to do with the AggLayer. Now, the type 1 prover ends up also allowing them to do that in an EVM compatible environment or an EVM equivalent environment. Whereas the AggLayer obviously doesn't care. And so our view is kind of like the type 1 prover is there for those who want to use it. It adds a layer of security that you might not have otherwise, but it doesn't mean that you have to use it. And we don't really care, frankly, whether you use it, because ultimately you get the benefit of these cross-chain interactions through the AggLayer in a secure way due to the specific mechanisms that Brendan was touching on earlier.
All right. And then last bit that I just want to ask about, you also announced a new proving system called Plonky 3. I didn't have enough time or just couldn't understand exactly. So this is, I guess, one of the systems for the zero knowledge proofs, but I didn't know how that fit into everything else that we've discussed.
Yeah, sure. So I think a good way to look at it is like when we talk about the prover for a zkEVM, that's like, you can think of that as like, we are like running the EVM inside a zero knowledge proof. And some proving system is generating proofs that show that the execution of that EVM or whatever VM was valid, given sort of a certain output and a certain set of transactions. And so the like Plonky 3 is kind of the proving system that's like the underlying technology that allows that to happen. And we previously released Plonky 2, and I think it might be like the Plonky branding might be some of the worst branding in the entire industry. I'm not sure that we're like successful in kind of like naming those proving systems, but we're really excited about Plonky 3 because like Plonky 2, when it was released, was I think between like a 10 and 100x improvement on all other proving systems that were compatible with the EVM that can be verified on Ethereum. And Plonky 3 is like between 5 and 10x faster than Plonky 2. And so this ends up just meaning that we can generate proofs faster and at lower cost for users. And like, given that proving cost is passed on to users, it just reduces the cost of using systems that use zero knowledge proofs.
All right. So in a moment, we're going to talk about how they get a critical mass of applications on the AggLayer. But first, a quick word from the sponsors who make this show possible. Polkadot is the original and largest Layer 0 blockchain with over 2,000 plus developers. And the anticipated Polkadot 2.0 upgrade will be a massive accelerator for the ecosystem, upgrading the infrastructure with 8 times higher transaction throughput and twice as fast block times, perfectly tailored core time for the needs of every protocol, trustless bridges internally and into Ethereum, Cosmos, Near, Binance Smart Chain, and revised tokenomics and the implementation of a token burn to reduce inflation. Perfect for GameFi and DeFi to build, grow, and scale with one of the most active crypto communities in the space. Polkadot recently announced a partnership with Mythical Games, bringing top games like NFT Rivals with over 650,000 players and 43 million transactions to pave the way for GameFi and the Polkadot ecosystem. Get your Web3 ideas to market fast with economics that work for you. Think big, build bigger with Polkadot. Join the community at polkadot.network/ecosystem/community. Back to my conversation with Marc and Brendan. So as we discussed, you guys have this AggLayer, but it's not quite up and running because there's just a few applications on it. So how will you get a critical mass of applications on it? You know, what are your plans for generating a network effect on the AggLayer?
That's a really good question. I'd say that the one important thing about the AggLayer is that it is very neutral. And what we mean by that is that this is not a thing that is about kind of Polygon. It's about bringing kind of all of these modular chains together. And that really resonates with developers because ultimately every developer who is building a chain knows and recognizes that there are downsides to sitting alone in their own environment. This is true even for like a monolithic chain that can become part of the AggLayer, but it's even more true once you start getting much more specific to an app chain. And when you think about that app chain, what they need to do is they need to recreate everything that exists in another blockchain that their users need. And that is a big burden that if you're talking about thousands of chains existing, and we're really not that far away from that at all, you're talking about a lot of like repeated lift. And these developers, they don't want to do that. They don't need to do that. And so when you present them with the AggLayer and you say, here's a solution that is going to allow you to not have to build an entire DeFi ecosystem, when all you care about is being able to create an amazing NFT experience for users, that is something that is very desirable. And it's not really, honestly, about selling it. It's about showing them why it is that they can actually do that in a safe way with low latency that creates a good user experience. And when you show them those three things, they're like, oh, great, I don't need to go build this all from scratch. And it becomes kind of a very easy decision. And that's why, there is a lot of interest in the AggLayer for that reason. And so that's like we'll call like the really app chain specific discussions. I think on the other end of that, you could take things like L1s themselves. And that's one of the things that's interesting about the AggLayer, right? Like, so we do work on like layer 2s, but the AggLayer isn't just welcoming to layer 2s. It can really welcome anyone into the environment. And so when you think of an L1, ultimately what you have is a chain that has a lot of advantages for their users from like what's called a unification perspective. But ultimately there's things that those users probably want that exists in another environment. And they have to go through an even more painful process than the one Brendan's really been kind of trying to describe within like the Ethereum world. When you're going from, Solana to Ethereum, it's much more difficult, right? But when you start thinking about kind of L1s and you say, okay, you can actually share users with Ethereum and liquidity with Ethereum, then it starts becoming a lot more desirable. And so do I think that the biggest L1s will become part of the AggLayer, like right up front? Like, of course not. Do I eventually think that you get to a point where more and more L1s, and we are having discussions with multiple L1s who are very interested in joining the AggLayer. The reason for it is simply because like smaller L1s realize that there are a lot, like the advantage Ethereum's always had is a lot of users and a lot of liquidity. And so why wouldn't they allow their users to participate in that? And when you think of the AggLayer, we talk about it in the sense of like unifying liquidity, but you're actually unifying users as well. So if you think about it, you're saying, hey, I have a lot of liquidity on my chain and I need to attract users there. Well, one way to do that is directly attract users to your chain. Another way to do that is say, hey, I'm going to create the deepest liquidity so that when somebody wants to do a DeFi transaction on chain 12 on the AggLayer, then that transaction is going to get routed through that pool. And by default, when you join the AggLayer, you're acquiring a set of users that you wouldn't have otherwise who are going to interact with your chain via the AggLayer. And so ultimately, you think of like that end of the spectrum of L1s. They're like, okay, I can maybe get my users to get deeper liquidity somewhere else or a different kind of application that they can't access. Or I may actually acquire more users where it is that I have an advantage within that ecosystem. Like that is desirable. And so ultimately, like I kind of view it as like the app chains makes most sense. And then with time, it kind of like moves along to where you start looking at like more monolithic chains that say, hey, I want to take part in this environment as well.
That's so interesting that you're also talking to layer ones. But are you noticing, like, because I would imagine that there's certain types of chains or certain types of applications that kind of are more interested. Are you noticing any trends in that regard?
I mean, very interestingly, I don't know that there is a trend. I would say that when we look across general purpose chains, again, the biggest hesitation for an L1 is to say, I don't look like an L1 anymore if I join the AggLayer. Except it's not really true. You can still have your own consensus. You can still have your own execution environment. That's not really true. And so when the initial reaction that you get from most of them is like, hey, like not interested. And then you dig into it with them and they start realizing, oh, I can actually truly remain an L1. Okay, this is something I actually want to talk about. And so L1s are the most difficult conversations, but once you start having them, they realize there's a benefit. But then when you start looking across, whether it's DeFi naturally comes to folks, right? So like everyone in DeFi knows that like, hey, if you can get access to more liquidity elsewhere, I want access to it, right? And so those are like very, very easy conversations to have. But they also exist in like the gaming environment, right? So people are creating like specific chains for games. They understand that if there can be deeper liquidity in NFTs or their users can receive deeper liquidity on another chain, that's better. Or if they can attract users from other chains, that's better. So like those have been pretty easy conversations. They kind of deepen similarly. I really don't know that there's like an area that I look at beyond L1s where it's like more difficult conversations. But again, even the L1s, once you start digging into why it is that they can remain independent, and maybe that's a point to touch on really quickly that's important, which is like one of the things that we really have been focused on with the AggLayer is allowing every chain to remain completely sovereign. This is something that was really important in the Cosmos ecosystem, and they did it really, really well, maintaining that sovereignty for a chain. The way that I kind of look at it and approach it is it's one of those things where you should be allowed to stay your own independent chain with your own independent community and benefit from the other chains that are in the ecosystem. Alternatively, you also have the option of becoming part of this like bigger ecosystem where you can opt in socially, not just from a technical perspective, but like socially, you could say, hey, we want to actually build together on top of the AggLayer. And when we actually talk to each other, one chain talks to another chain, we can actually build even more interesting things for all of our users. But that's not something that anyone's forced into. They can remain completely sovereign and build their own thing.
This is just so fascinating because it's kind of interesting. It's like you have Ethereum as a base layer, and then there's this, layer 2 on top. But then it's like you have a Cosmos on top of that, a Cosmos-ish type thing on top. Anyway, but it's a zk. It's just fascinating. But one thing that I wanted to ask was, so I guess I didn't either think of this before or didn't come across this, but are the transactions private or are they public?
They're public. I mean,
okay.
You could have like one interesting thing is that like with this sovereignty over execution environments, you can have chains that are private that can interoperate really seamlessly with public chains. And so like Polygon Maiden is one of these that's really looking at client-side proving and privacy. And I think it's really powerful to be able to like have a highly scalable private zone that you can access from anywhere in the ecosystem.
And out of curiosity, like if this AggLayer is based on zk technology, why haven't more people thought about having private chains?
Well, I think that a lot of the way that chains are architected and a lot of the tooling that currently exists for EVM chains and SVM chains really depends on transactions and application state being public. And so I think it's just a lower lift for developers to like work in the paradigms that they are familiar with and already have tooling for. And so I think that drives the move toward more public chains.
So as far as I understand, Polygon's intention to build using zk technology started back in early 2023. Why did you decide to do that at that point? What was it that you thought that this technology would enable that, was the future of the crypto space?
Yeah, so I think the move internally with Polygon towards zk started actually in like mid 2021 because I think there was the realization internally that the Polygon PoS chain was seeing a lot of traction and it was fulfilling a short-term need for that Ethereum had, which was to scale and to escape the limitations of the L1. But I think that the founders of Polygon deserve a ton of credit for recognizing that this was not something that was going to persist. Like the technology that the Polygon PoS chain is built on was not going to be the technology that Ethereum would be operating on, in 2030. And so they made a really big bet on acquiring 3 zk teams, of which my project was one. And yeah, we were sort of working kind of in the background for 2022 and in 2023 launched the zkEVM, which was a type like 2.5 zkEVM. And yeah, we've been really focused on both pushing the underlying technology through R&D. So that's where Plonky 3 comes in. And I think that it's fair to say that Polygon has really been setting the standard for zk performance and efficiency in the industry. But also, I think it's about building on top of those core technologies, and so enabling things like the AggLayer and like zkEVMs and Polygon Maiden. I think those are kind of the two prongs of the Polygon zk strategy. Is like very much deep tech R&D of underlying proving systems, and then like taking that technology and figuring out what we can build to actually serve users.
And one of the things that we don't actually like that people don't really think about is like you kind of had two options at the time when it came to scaling, right? It was like the optimistic roll up kind of approach, or it was the kind of zk roll up approach. And when you analyze that at the time and kind of took a deep dive, it was actually pretty unclear which way would be better to most people. But I think that with time, and one of the things that we've realized is that the costs and performance of proving have increased so drastically, or the cost has decreased and the performance has increased so much that I think a lot of those concerns that existed at the time, very quickly the team realized, actually, we need to double down on the ZK technology because it really actually is the path forward. And I think, as Brendan was touching on earlier with the type 1 prover, it's really coming to fruition in that we are, even internally, and I think we have the best ZK researchers maybe in the world. I don't know, Brendan, maybe correct me, but I think that most people view it that way. We are even outperforming what we expect internally. And so it's just become very evident with time that the ZK tech will get to the performance levels that you need to be able to build purely using ZK tech without the downsides that you get with the optimistic rollups.
There's this really interesting narrative that exists that where people look sort of superficially at the costs for users in optimistic and ZK systems. And so they say, okay, well, in ZK systems, maybe you can save a little bit on the margins in call data because you can do compression and state diffs, and you don't need to post signatures on chain. But I think the proponents of optimistic rollups would say that costs will be strictly worse for ZK rollups because you need to pay for proving, you need to pay for the verification of proofs on Ethereum, and in aggregate, this adds up to be strictly greater cost than just posting transaction data. And I think that's a very superficial view because it misses the aggregate costs that are borne by users. And the biggest cost that's specific to an optimistic rollup is this imposition of a delay in withdrawing from the chain. So on most optimistic rollups, you need to wait for 7 days in order to withdraw funds via the native bridge. And users obviously are unwilling to lock funds, and so they use third-party bridges to avoid this delay, to avoid the requirement to lock up funds. But if you look at what the aggregate costs are that are borne by users to use third-party bridges, like on Arbitrum, for instance, there has been a total of between $35 and $40 million, depending on what the price of ETH is, that has been borne by users to avoid the withdrawal period. And if you compare that with the cost that it would take to just prove every transaction on the Arbitrum mainnet using the Polygon Type 1 prover, it's 100x cheaper to just prove all of those transactions and get rid of the withdrawal period. And so if you look at aggregate costs, then ZK rollups are actually much, much cheaper than optimistic rollups. And they will continue to get cheaper as we improve the underlying technology and reduce proving costs further.
Yeah, I think some of the groups maybe that went down the other path, that I don't remember. I feel like there was a very long ago blog post by Vitalik where he kind of talked about the timescales on which he expected different things to happen. And I sort of feel like this is, it's just playing out a lot faster than maybe people expected. I did want to ask about the zkEVM rollup, which it is in beta, but there was an incident on March 23rd where it stopped processing blocks. Can you explain what happened there?
Marc, do you want to take this or should I?
I'll let you take it, given the technical description that you made.
Yeah, sure. I think when you look at sort of the deployment of L2s, there's usually a period of and this is true for optimistic rollups as well. There's a period of a year where teams realize that the configuration that they launched their rollup in, specifically with regard to the client, is maybe not the best choice for the long-term maturity and sustainability of that rollup. And I think just being totally candid, there were decisions that were made in the Polygon zkEVM rollup, specifically around the client and using a custom client, that have led to technical debt that we're currently addressing. And so the specific outage was just an instance where there was a bug in the client that affected the prover, and we just needed to mitigate that. But I think that as the technology progresses, and we've already seen this with the type 1 prover, it allows us to use existing Ethereum clients. And this is like a move that I think Arbitrum and Optimism both went through, where they launched with like custom clients and then they moved to existing Ethereum clients. And we're sort of mirroring that process. It's just, a year or two later because we launched a year or two later. But I'm really, really optimistic, and I feel really positively about the long-term health of the zkEVM rollup as we make those changes and move to existing clients, move to more mature proving technology. And so I think from our perspective, like, we are really, really happy to continue to bet on the exponential development and growth of zk technology. And I think that will just play out on like longer timeframes than, the first year after launch.
So the week that we're recording, Marc, you set up a conversation about layer 3s with a tweet that said, quote, L3s exist only to take value away from Ethereum and onto the L2s on which the L3s are built. You do not need L3s to scale. Explain what you meant by that.
Yeah. So, one of the things we talk about like inside Polygon is like, why have L3s when you can have L2s? And the thought process here is like, why do we need L2s in the first place? And the answer as to why this was contemplated by kind of Vitalik and others in the Ethereum community was because the L1, the way it is right now, is great for decentralization, great for security, and it's not great for scalability. And so we needed something to scale, and that's where the L2s come in. And when you look at how the L2s are doing from a scalability perspective, what you see is they're actually doing pretty darn well, and they're continuing to improve all the time. And so when we fast forward and we look at like a year from now, we say, are we going to be at a point where we can scale Ethereum to its limits through L2s at a cost and user experience that is unique to like the apps and the users that as they need it? And the answer is yes. You will 100% be able to do that. So, people talk about like L3s for like native gas tokens. Okay. Polygon CDK, which allows for, L2 rollups, allows for a native gas token, your own execution environment. Okay. You could create your own execution environment in L2. You can like go through like the reasons for having an L3, and L2 satisfies them like every time. And so the simple point is that when somebody says, I want L3s to build on my L2, what they're saying is they want to capture more value on their L2. And I have no problem, by the way, with L3s. L3s will launch on Polygon PoS. They'll launch on Polygon CDK chains. Like they'll launch on top of Polygon zkEVM. L3s can launch as much as they want. If somebody finds it desirable, it's a permissionless system and it allows people to test. So I have like no problem with that. The statement was really about like L2s who are trying to capture broader, more of the market. And if you think about like L2s doing that at scale, in my opinion, it becomes problematic for Ethereum when everything gets built as an L3 on top of one specific L2, rather than across L2s, all of which are connecting to Ethereum.
Yeah, well, I did want to ask about, when you said that you felt the layer 2s could scale quite well, you probably saw how after Dencun, transactions did increase on Base, but also the fees went up quite a bit. I just quickly pulled up an article saying that they went to about 9 cents. So as you know, there's this layer 3 degen on Base. And I was curious, like, do you really think Base isn't necessary, or sorry, degen isn't necessary for scaling or on that chain, or is it more just about the fragmentation issue, or what's your assessment of what's happening there?
So the issue with fees on Base was related to congestion prices. So like their instance of the EVM can only process like a certain number of transactions per second. And so if there's sufficient demand, then they will see fees increase. And that those fees are being driven by congestion on the EVM. They're not being driven by like the cost of data availability on Ethereum or like, obviously not proving cost. And so I think like to Marc's point, if you think about like the topology of like the ideal scaling setup for Ethereum, like actually L3s have a real downside, which is that they are not like each L3 is connected to the specific L2 that it settles to. It can't like directly access the state or liquidity on an L3 that's not also settling to that L2. And so when we think about like the AggLayer, fundamentally the premise is that we can add block space in an L2 configuration. So every L2 on the AggLayer will or L2 supported by the AggLayer will settle directly to Ethereum, and those L2s can all share state and liquidity seamlessly between themselves. They don't need to like route their transactions or messages or requests like via L2s to access a particular L3. And so I would say that like the AggLayer is not like, it's not an L2. It's like a layer in the same way that like a DA layer or like an execution layer is a layer. Like I think the term layer is sort of overloaded, but it enables like the same level of connectedness and composability that an L3 would have with an L2 or with other L3s that settle to that same L2. But instead, we can just make everything an L2 that settles to Ethereum. And so there's no, I think it just reduces complexity because you don't need to have like an L3 that like settles to an L2 before it settles to Ethereum for if you want to withdraw funds to L1. And we can preserve this like universal connectedness property that we don't get necessarily with L3s.
And if you take this to degen specifically, you could look at that and you could say, degen could have just launched with all of the same features and extremely low costs as an L2. As Brendan said, the issue with Base is actually representative of why L2s make a lot of sense, which is that, I don't think you're going to see most L2s be general purpose L2s. You're seeing that now because it's just frankly where we're at in the ecosystem, but you're going to see most L2s that are going to be specific to something, just like degen, right? Like it's going to be like specific to something. And when that's the case, the amount of time transactions users that it takes to actually drive a chain to actually be bottlenecked in any way whatsoever takes much, much, much longer. And you don't get into the issues that you got in with Base, for example, which is a throughput issue as a result of lots of different use cases actually being on one. And so degen can just sit on its own for its own specific purpose as an L2 without the congestion problems that you get from a general purpose chain.
Okay, well, now let's talk about how there's two big developments on Ethereum that are happening or will happen. One is, as just came up, there's now this modularity with data availability layers that are coming out. Obviously, Celestia, there's a Veil. All of these allow layer 2s to scale more easily. Another one is EigenLayer that will allow restaking of Ethereum to provide security to other chains. So I wondered how these developments mesh with the AggLayer, if at all.
So the nice thing about the AggLayer is that it's designed to provide chains the flexibility and the choice to use whatever data availability solution they want to. So if a chain wants to retain maximum Ethereum security, it would use Ethereum as its data availability layer. If it wants to optimize for cost or for some other property, it could use Celestia, or it could use like a data availability committee in a Validium mode. And so we're fundamentally agnostic with respect to like the choice of data availability layer. I think EigenLayer is a really interesting case. I think actually that like the crypto economic sort of like trust guarantees that are provided by EigenLayer are actually like not as good a fit for rollups, which can offer a greater level of trust via validity proofs or fraud proofs. But yeah, so I think that validity proofs are going to offer a better trust guarantee than the crypto economic security that comes from restaking. So that's where I think I think EigenLayer has really, really interesting applications in DA and in other instances where it's difficult to have validity proofs or fraud proofs, but I think for rollups they will still be dominated by validity proofs specifically.
All right. So obviously we spent most of the episode talking about the AggLayer, but are there any specific things you're focused on with your proof of stake chain?
I think the upgrade to zk. So actually, it's sort of the end of an era for Polygon, because when I joined Polygon, it was in the middle of this war over L2 definitions, and specifically whether or not the POS chain was a side chain or an L2. And it's going to be strange now because the POS chain will become an L2, because we will be eventually generating validity proofs that show the validity of every transaction. And so I'm not sure that we've decided whether it will be a Validium or a rollup, given the reduction in DA costs on Ethereum. But yeah, I think that'll be a really exciting step for the POS chain.
And when do you think you might have a decision on that?
So Marc, do you have a sense of the? I don't know. That I think it's ultimately up to the community and to the users of that chain when the upgrade happens. But I think we would love to see it sometime this year.
Yeah. And one of the other things that we're focused on for Polygon PoS is bringing it to the AggLayer as well. So one of the things that the AggLayer is going to benefit from, I was touching on a little bit earlier, is a very mature chain that has so many connections, into kind of different centralized exchanges who can ultimately make it very easy to onboard to all of the chains into the ecosystem. And so in a few months, we'll be connecting Polygon PoS to the AggLayer, which will allow for that to happen. And the ZK kind of upgrade will happen after that. But the general idea then is you'll have all of the liquidity, all of those applications that are available in Polygon PoS and have been building up for years will be available to all the other kind of users using other chains in the AggLayer.
All right. So EIP 4844, Dankun hasn't gone live on Polygon yet. I guess you're in the midst of some other upgrades. So when do you expect it will go live? And what else is on the short-term roadmap for Polygon?
Yeah, so I think in the next 4 or so weeks, we've been really focused on the AggLayer and sort of building around that versus like the Polygon zkEVM chain has been in beta and there have been identified issues that we've been kind of focused on there. But I think in the short term, upgrading the proving tech, moving to 4844, I think that we will see like between a 10 and 20x reduction in proving cost as we move away from the existing proving tech. And so I think that's something that's really exciting, and like getting to the point where we have like sufficient reliability and sort of, it's ready for greater adoption, I think will be a really exciting step for that chain.
Yeah, and I tend to agree. Like once we've talked about the AggLayer a lot, so I won't dig into that more. But once you get past that, I think like bringing Polygon PoS to the AggLayer is going to be very important for other chains in the AggLayer. And then beyond that, it is zkEVM. And we've spent a year, a lot of people probably have recognized this, is we haven't pushed it very hard. And it's because of some of the things that Brendan's been talking about. And in the next couple months is when we are actually addressing all of those. And so having a system that will have matured over kind of the last year and then bringing kind of new tech to it will bring us to a point where I think we'll see a lot more excitement around Polygon zkEVM. I think we'll be pushing it. I'm confident we'll be pushing it in a very different way than we have been. And I expect that to bring a lot more use than what we've been trying to do, which frankly has been, let's just let the system mature. And so once we get past that, I think then the entire focus is going to be on continuing to grow the AggLayer with zkEVM and PoS alongside of it.
Oh, I was just going to say, I think the onboarding of PoS to the AggLayer is like sort of a symbolic step, because if you think about like there's sort of this like structural flaw that I think exists for L2s, which is like Marc alluded to this earlier, but you have to like not only launch a chain or like do the thing that you have a comparative advantage in, but you also have to like play these games around tokens and airdrops and liquidity mining that will like bootstrap enough interest and liquidity and momentum for your chain to actually succeed. And I think that this is like a structural flaw for Ethereum. Like it's a process that's really, really inefficient. And it's something where like I think it's an impediment to builders being able to just focus on building their DeFi primitive or their game or their NFT collection. They also have to focus on like these sort of like token games and bootstrapping liquidity and like building a financial ecosystem in addition to a product. And Polygon PoS was kind of the original, like I think in many ways like Sandeep sort of wrote the playbook for using tokens to like bootstrap liquidity and interest on a chain. And so I think it will be sort of symbolic to see that like original instance of that playbook being run, joining the AggLayer, which is basically supposed to solve this problem. It's supposed to like create this unified pool of liquidity and state that can just be plugged into by developers. And like they won't have to worry about like bootstrapping liquidity and like doing liquidity mining incentives and like, you know, doing things that I think are arguably like very, very inefficient from the perspective of the ecosystem. And so I would just call that out as like something that like I'm personally excited about, and I think will be positive for the space.
Yeah, and not even inefficient, but even like bad, you know. Yeah, creating sort of the what do they call it? The set of mercenaries as opposed to missionaries, and just creating a lot of speculation and not quite pump and dumps necessarily, but yeah, it's just a lot of activity that's more speculative rather than like building something substantial. So, all right, you guys. Well, this has been super fascinating. Where can people learn more about each of you and your work?
So I'm on Twitter at _B Farmer. I don't know if it's appropriate to like talk about our personal Twitter
accounts. That's why I asked. Yeah, to get your handles.
I'm not a very prolific tweeter, but yeah, maybe Marc's a better follow than I am.
Not sure about that, but I'm on Twitter or X at 0xMarcB.
Perfect. Well, it's been a pleasure having you both on Unchained.
Thanks for having us, Laura. Thank you.
Thanks so much for joining us today. To learn more about Marc, Brendan, and Polygon, check out the show notes for this episode. Unchained is produced by me, Laura Shin, with help from Nelson Wong, Matt Pilchard, Juan Ivanovic, Megan Kavis, Shashank, and Mark Akuria. Thanks for listening. Unchained is now a part of the CoinDesk Podcast Network. For the latest in digital assets, check out Markets Daily, 5 days a week, with host Noel Atchison. Follow the CoinDesk Podcast Network for some of the best shows in crypto.